Ugh, I am so grounded. My mom says I can't go anywhere until I clean my room. Everything is a mess. Just looking at my dresser gives me a headache. None of my socks match. I have t-shirts in every drawer. And my favorite pair of shorts, it's missing. Every day I feel like I have nothing to wear. My mom says if I were more organized, I would see that I have plenty to wear. Well, I may not be organized, but chemists are. How do chemists keep track of all their stuff? I mean, after all, matter is anything with mass that takes up space. That's a lot of stuff. Well, turns out it's all easier to understand if you organize it into smaller groups. Here's what I mean. All matter can be classified as either a pure substance or a mixture. When you think of pure substances, think about basic building blocks. Pure substances can be broken down into two categories, elements and compounds. Water is a pure substance. It is a molecular compound made of hydrogen and oxygen. Water is a pure substance because it's the same no matter where it comes from. Whether it comes from a bottle or the filter at your grandma's house, water will always be H2O. It will always have 2 hydrogen atoms and 1 oxygen atom. The ratio of atoms in a pure substance never changes. So the water from the bottle has the same physical properties as the water from grandma's house. Pure substances have a uniform composition and cannot be broken down into simpler substances without breaking chemical bonds. This is copper. Any element on the periodic table is also a pure substance. If you've got change in your pocket, there's a good chance you've got a few copper pennies in there. But hold on, pennies aren't pure copper, and they're not a pure substance either. Pennies are a mixture of different metals. A mixture is a substance made by combining 2 or more different materials in such a way that no chemical reaction occurs. A mixture can be a solid, liquid, or gas. So pennies are a mixture of copper and zinc to make an alloy. Bronze, brass, and steel are also alloys. So pennies and other alloys go over in the mixture category. Mixtures can be homogeneous or heterogeneous. Alloys are homogeneous mixtures because the composition appears to be uniform throughout. The metals in them are not chemically bound like in a compound, but held together by something called intermolecular forces. Here's a picture of the necklace my boyfriend gave me. Ha ha, just kidding. It's actually a picture of a necklace found in a tomb in Egypt. So what about this bling? Gold is an element. Is this bling pure substance or a mixture? Well, that depends. 24-karat gold is pure gold, but 14-karat gold and 10-karat gold is a mixture of gold and other metals. In a homogeneous mixture, there are a bunch of molecules or compounds hanging out that are evenly spaced so that the composition appears to be uniform. Components of heterogeneous mixtures are not evenly spaced, and the components are visibly different. The other thing you need to know about mixtures is that their individual parts or pieces can be separated. This is because the elements or compounds that combine to make the mixture retain their physical properties. So because they are not chemically bound, they can sometimes be separated based on solubility, particle size, melting point, boiling point, freezing point, density, polarity, and magnetism. All right, so some samples are easy to classify and some are not. But here are a few questions you can ask yourself to determine what type of matter you're dealing with. Is there only one substance present in the sample? All right, let's say you're asked to classify ice cream as a pure substance or a mixture. Well, you know that ice cream is made of milk, sugar, and vanilla. More than one substance is present. If the answer to question number 1 is yes, then you've got a pure substance. If the answer is no, then the sample is a mixture. Ice cream is a mixture because more than one substance is present. Peanut butter, sand, and air are also examples of mixtures. All right, let's forget about mixtures for now. Question number 2 to ask yourself is, if the substance is a pure substance, can the sample be broken apart further by chemical means? All right, well, let's say you've been asked to classify table salt. Well, salt is made of sodium chloride. Only one substance is present. So the answer to question number 1 is yes. The answer to question number 2 is also yes, because salt can be broken down into sodium and chlorine atoms. If the answer to the second question is yes, the sample is a compound. If the answer is no, it is an element. Other examples of common compounds include sugar and carbon dioxide. Now consider mixtures and ask yourself the third question. Is the sample of constant composition? If the answer to the third question is yes, then the sample is a homogeneous mixture. If the answer is no, it is a heterogeneous mixture. What about that peanut butter, sand, and air that was mentioned earlier? Given any mixture, I like to ask myself, is the sample smooth or bumpy? Creamy peanut butter would be a homogeneous mixture, while crunchy peanut butter is heterogeneous. If you can pick out pieces, then it's probably hetero. Sand is a mixture. Can you see how there are different particles in the sand? Little rocks are all randomly mixed in. The composition is not constant, so sand is a heterogeneous mixture. But what about air? Air is made of nitrogen, oxygen, and a few other elements mixed in there. Air molecules expand and mix evenly. So the answer to the third question is yes. The composition is constant and air is a homogeneous mixture. So ask yourself these three questions next time you have to classify something. Or picture this chart. You got this. So I was kind of hoping you could help me reclassify my closet. No? All right, I better get started on that. Being grounded no es bueno. All right, until next time, see y'all later.